So I think we want. I'm just
looking at this again.
Yeah, I mean,
now it's go ahead.
It's worthy of. Go ahead.
I was just going to say that now that we have Edwin here, he can tell us some of the crazy
stuff. What are we looking at?
That's what we'd like to know. Welcome to the April 17th edition of the Electric View. I'm Neil Thompson. Today we have David, Buddy, Cameron, Edwin, Heather, Jim, Peter, and Richard. We are discussing the electrical nature of crystals, geodes, and the underground formations responsible for some of these amazing gemstones. Please take a moment to like and subscribe below.
They have. You'll see the name of it come up. They label it generally.
Solution and then crystallizing, or
yeah, I think that's what it is. The
oh wow,
yeah. And to be frank, this is something I was very interested in. Yeah, is the relationship between chemical growth that we see obviously in caves, but also the electrical nature of caves, because there are certain situations which we become incredibly questioned, like when you see those gigantic crystals in that cave in Mexico. Or you see things that don't look right, like ribbons of rock. How did that drip that way? Did that drip that way? Did that even happen? Why didn't it turn into stalagmite? And of course, electricity begins to, you see crystals pulled out of rock. You see veins, as we've seen in our geology tours. So we have a decidedly different point of view there. But one can't argue that crystals can grow in certain solutions, and over time, we don't know how, even thousands of years, you can get pretty amazing sculptures with it. But this is one of the things I've been wondering myself. I want to refine that argument so that I can say, no, crystals do grow in solutions, but electrically speaking, this is how caves work. Like that Vietnam cave, so big, without one rounded rock in the whole friggin' thing. And I'm supposed to believe that it was worn down by water? I'm questioning that.
Yeah. What's the electrical
this is
action?
I think what you're seeing here is more or less the dendritic growth patterns of the crystalline veins, right?
Yeah, let's see what they're talking about here.
No, that's another level, of course, but
yeah.
Well, one can't deny that even
it's electric in nature. So meaning the dendritic growth kind of follows the lightning pattern, just like the crystalline veins, right? And you can see it in the growth as well. There are certain points where the growth is happening dominantly.
And I think you're right. I definitely see situations where you have a beautiful, like even concrete over time will start to, bleed limestone, I guess. Have growths off it. The question is, like these fine spires, stuff like this. When you're seeing these, that's a chemical reaction. But how did the substance get in there in the first place to, like, that weird substance that start causing this? Some of these crystals that are made are clearly pinched, and perhaps maybe Markland convection separates the elements inside and so forth. But then, go ahead.
It's mineralogy, right? A mineralogist could educate you far better than I could in this specific topic, at least, right?
Fair enough.
But it's the elements and their properties that dictate these shapes, or the solubility, or what reacts with what and deposits in water. You see watery chemistry here. But what I think you're referring to, Neil, is electrochemistry, meaning ionized plasma, and then falling back, when it cools down, loses its energy, It's going back to a molecular state, and the molecular state is what you see here, all these salt growths, etc.
That's my interpretation as well. That is exactly the interpretation I have for caves. Besides, of course, lava tubes or something like that,
all that stuff is real, what we are observing, right? It's all real.
Yeah. I mean,
but crystalline veins are quite mysterious, and they are called, what are they called again? Those geode shapes.
Concretions?
No, there's another specific word for it. But
okay.
All those beautiful amethyst geodes, for example, those big ones. I'm sure everybody's seen those, right?
Yeah.
Kind of like fulgurites.
They're kind of like, they're separated. So it's just a hole in the ground with that quartz and crystal all there.
These, right?
Yeah, so they're often not even part of a vein. They're separated. Now, how can that be, right? By cooling process? I think it's exactly the reverse. I think it's, because of
high heat.
Process.
Yeah, I think that they were like a plasmoid in the rock that just melted.
An ionized plasma. You can see that's the agate around it. That's the molten rock, the original rock, if you will. And the growing crystals on the inside of the geode, in my mind, is the deposited gaseous substance there, right? The ionized.
That's how I picture it too. Especially if you stop for a moment. Don't scroll down. In the upper right, or now it's in the center right. There's not quite the round one. I'm pointing at the screen. You can't. That one. Okay. There's a bump on the bottom, and there's a divot on the other side. You see what I mean? So it shows a polarity. And it's thicker along the equator of the object, usually. And this is how you can tell if you have a geode.
I have a bunch.
Well, and you can see these properties.
That nugget is always there.
Well, that's in my opinion, this is showing you the current flow. And this is like a magnetic field, like the donut pinch, if you know what I mean, like the donut. And this is sort of like a plasmoid in the rock. And then the same thing occurs with a concretion in the sky, in my opinion. You have a concretion. Its material has been lifted. It's been crushed into a sphere. It may or may not have a geode core, and then it is piled up with material as it begins to stick to it, because this thing begins to get a different electrical potential than the Earth, for example, and stuff sticks to it in layers, and then this thing crashes back down to the ground and continues to get buried with the rest of the stuff. That's my interpretation of these two events. But I see this as just look how beautiful it is, and to imagine that the gases were in there and being pulled by Markland convection, because we've noticed in geology that only, like, for example, there's a crystal and a particular material like niobium or something, very rare, but it only occurs on the tips of the crystal, and that is where we have to get it. And that's the only place to get it in nature. And you find stuff like this. This is why this idea that you had of electrotransmutation, Edwin, has such promise if you could begin to recreate some of these things. Because
I think
I mean, that's where you start looking at these in a different way, and it's much more exciting, of course. Yeah.
I think that's what geodes are, your Z-pinch or something to that effect, right?
Well, they have polarity properties, and you only get polarity properties if you have like a polarity, like direction, and you need a direction, and therefore, if you had a rim, then you have a magnetic, probably a pinch, like you said, and it has a ridge where it can't pinch down as much, which is in the equator area, which is why it's thicker. The other parts can rip off. This part can't. It's very interesting.
Yeah, I think it potentially triggers fusion processes.
I would say so.
In all the heat, depending on what materials are there, depending on what the current is, depending on, all that. Well,
this would be a lot of magnetic, like obviously if it's pinching, that's a magnetic thing in the middle of that. Magnetic, with like literally like a black hole shooting positive ions one way and electrons the other way. It's something to that.
Well, that's the way it's basically an inverse of their model. And in a way, how they have the model. Anyway.
Well, this is a perfect example. As you can see, there is lots of other fulgurite-like ones that are mangled beyond belief. So this is not a perfect thing. Well, to me, these are like when we watched Buddy do his fractal branding, when he was burning a pathway, you see these little flare-ups and stuff. Well, this is where those things could happen, and then they get lodged into the rock, and they're there. They're permanently part of it now. And, I could envision that. Doesn't mean it's true, of course. But
yeah. I mean, I wonder what happens when there's, on the, just you go down a scale, because I was thinking about how you would emulate this and show that there's transmutation.
We can go up a scale.
Actually experimentally do it. Go ahead.
Well, no, I meant, have you seen the giant crystal caves or anything like that?
Yeah.
The one with the ones you can walk across, the crystals you can walk down.
Okay.
Well, just type it in because it blows my mind just looking at it.
Yeah.
But that's crystal on the edge of a, crystal cave. It's in Mexico. Yeah. Yeah, those are they.
Yeah.
Those are people walking around in them. But it's they're wearing.
That is up a scale.
Yeah, that is up a scale. And they're wearing protective suits with oxygen tanks because it's 160 degrees in there. And because it's right beside it's right beside a volcano. So we're right beside the plasmoid that is in the center of this volcano, if that is indeed the case of what we interpret this to be. An electric volcano.
Nice.
So
see, they're calling it a theory. I think that's fun. That's amazing.
Yes, and I'm. It makes me question the idea that water would do that. You can go, okay, well, if it was immersed in a solution, okay, and then if this happened, but it looks like it was pulled, like when this thing did its shock waves or whatever, it pulled like material right out of the rock.
It's right next to a volcano.
Well, yes, there is a giant, what's that, magma chamber, because this is about 2 miles down or something. This was found at the bottom of a mine. So this makes me question all the stuff we see inside of the Earth now,
Just think about, the scale aspect of it is pretty, compelling, right?
Well, you're walking on them. These things are huge. And only
and then start pulling in the the electrical model of a volcano.
Well, that's what I mean. If that is electric, if we can accept that geodes and other things are probably electric in nature, then this is the next thing we need to understand, because this is a big event. We can interpret that there are kimberlite pipes in, for example, northern Canada, and they're basically large fulgurites, and inside of those we find diamonds. This is these huge tubes that are going into the Earth. And they look like places where, like say a northern footprint, because we're at that edge where they're above. Well, I don't know if they're exactly above 60 degrees, but they're up in that area. It seems that we have this area which is like, around between 30 and negative 30, so north and south of an equator. You get some neat stuff. Like so you can get some nice touching around the top and bottoms of that. You can get some connections. And this is where you get Thunderstorm Alley and Tornado Alley and all these things. And then if you go above 60, this is where the aurora is coming down, and what's below that. And then you get the jet stream going across that. And then you have the connection into the Earth that's induced, I assume. And this is where you get these kimberlite pipes. So if there was ever a connection from interstellar space, it would go down the northern parts of the planet and into those areas. So maybe that's what those are, really fulgurites, but on a massive scale. And of course, in the crystals they make are diamonds.
But if you think about it in amps, it's just like huge current. Right?
Yes, that's exactly what it is. And of course this leads into, we can pretend that we can talk about that, and normally we express amps going through metals and stuff like that. Anyway, I was just thinking, this is just cool. Like, where are we going to go?
Have they like use this as an exploratory model? Perhaps I'm sure there's that. Like, I mean, I haven't looked at this. This is kind of.
It's actually sealed off now. This was their only time that they were going to go down and explore it, because it's so dangerous. They can only be in there for 2 minutes.
I was wondering if anybody knows if our crystal growth in space, like if we've gotten into growing crystals in space.
I actually don't know. We should check that out.
That's one of the things I'm sure that they've done on the or whether they do it publicly or not. I'm sure they've done it on the space station. Right? Yeah,
I don't think it involves gravity or gravity affects crystal growth, but I don't know.
Zero gravity crystal growth.
Yeah, let's try that.
Yeah.
This is some amazing stuff, though. I mean, when you think about transmutation, Edwin's idea of transmuting while you're, what would that look like in situ? Because normally we're thinking about dropping currents across pieces of metal and stuff, but this is dropping it across rocks, and what materials would form to continue the pathway, the electrical pathway. How would it do that? It's very interesting.
Well, if David, could you open that little linky that I put in?
Yeah, hold on.
In this
a linky.
It is a linky.
A linky. Okay, like a slinky.
It kinda, but more virtual.
But faster, right?
Everyone loves a linky.
Linky. That picture over there. Can you blow that one up?
This one here?
Yeah. So,
Jim. All right. Hey, Jim.
It's Jim.
The veins, that yellow stuff, comes from deep down.
So they
this
say.
This is an electric path, right? And we see the vugs and these vugs. That was what I was alluding to. It's like a big geode, if you will, and that's sometimes filled with gold. That's the mother lode, literally. This thing.
Wow. Can we get him?
Well, yeah. Okay. Is he in?
Hold on.
Well, this kind of gets into...
there
no, he's not. He's black and white or whatever. Call him back. There.
Jimmy, yeah?
So...
Oh, yeah.
You were saying, buddy.
All right.
Yeah. So this idea gets us right into... if you pump a certain amount of voltage into the ground, like attracts like, and you can get veins of different mineral deposits, and some of the transmutations could be possibly happening with high voltage current, or even ultra low frequency current. Who knows, something like that, where it's sound based and it's not electrical, and this is like what Heather and I were talking about, as far as using the right voltage and frequency and just pushing it into the earth and creating veins of that type of structure, like pulling gold, really literally mineralizing out of the crystal lattice structure that's already there, the bedrock. You pick the bedrock and you can turn it into whatever you want, really.
Well, it seems to me it's like a reverse lightning bolt, like a tree, but then downwards. But it's still the tree is pointing upwards, so the stem is way down, and the little the little branches are near the surface, if you will. It looks like electric strike through pattern, but in my mind, the electricity may be coming from below.
Well,
maybe
yeah,
you can speak to that.
It does.
And if it's there, so duration is of course important. What kind of material there is important. The amperage, or what kind of electricity, what are we talking about, right? Is it flashing on and off? Is it pulsating? Whatever. But regardless, there's an electric discharge going on there, creating these vugs and geodes and veins and whatnot. And it can even, maybe even transport material a little bit, or a whole lot even, does chemical sorting, I'm sure. But in the end, I also suspected of, maybe creating elements in situ.
That's my interpretation. I think that you're dead on. I mean, that VUG alone, when I see this, I picture Buddy's current that we saw being made. And it's reaching up towards another current, but this other current's in the sky. So this is where, So you can't really deal with that one. That one's, it's never going to leave any marks. It might leave concretions that fall back down or whatever, but this is the one that's under the earth, but it's sustained. It is able to, there's something above it. Like, let's just picture this thing flying overhead with such a high voltage that it's pulling current out of the ground everywhere it goes. This is a part that was high up. It was able to sustain it for a period of time because it was the highest point in the area as this meteor flew overhead. Let's picture that, for lack of a better thing, a comet, maybe something highly charged. So this current is really thick in the middle. That's its main current pathway. And this VUG thing is a part of just, you could imagine Buddy's experiment, but inside of something not 2D, but 3D, and ensconced and heated. And that's where a lot of current went through, and it kept on getting bigger and bigger as it melted a bigger current pathway. And these crystals started forming because it's looking for places to keep once the crystals form, they don't conduct very well. Most of the time, I could imagine crystals do, but the molten rock on the outside of it certainly does. And that's what it's trying to go through, right? So it has to make it wider to deal with the fact that crystals are growing inside. I could picture it. I don't know if it's true or not, but that's just an idea that comes to mind.
Well, it might not be a one-time off event. It could be a continual current that is being pulled in or induced through the poles, even through Birkeland currents that are coming. It could be a core effect that's creating the structure here.
Well, I can picture it sustained for maybe a minute. It wouldn't need any more than that, depending on the current going through it. But this is actually not that strong a powerful thing. Like, because we're talking, I mean, if you want to know a real current, the one that made the valley right beside it, that's a real current. This is just an incoming rock. It wasn't even that powerful. I mean, don't get me wrong, not that powerful compared to, but we haven't seen something of this type of magnitude, the one that could make a VUG, that kind of thing. Nothing like that has come near the Earth since like maybe 535. You know what I mean? Like it's, nothing. I mean, Tunguska wasn't that powerful. The Great Chicago Fire wasn't that powerful. None of those were that powerful. Something more powerful than that,
When they take cross sections of these, is there like if you were to analyze the material of a cross section just across, like if you cut it there, right? Do you see different materials like
yes,
and what's the composition of those materials?
Layers and the whole geology makeup you can imagine, of course. So that's many possibilities. But generally speaking, you have cracks, layers, vaults, etc. But these
like Birkeland layers,
more or less shoot through it.
I think you could find cross sections, but as far as I can recollect, it sort of looks like Birkeland current-ish. You have rings.
I mean, you would think, right? I mean, these are good.
But that can be formed by water too. You can't be, and the reason I say that is because I've seen things that are dripping off of a ceiling, and I can't be sure that they were like made by water or not. I mean, I'm not sure. So
everybody speaks to that, right? That's a general accepted idea. These veins are created by water, hydrothermal veins, right? I think the whole idea is, well, they might exist to a degree, especially if the calcium carbonate, limestone and all that stuff. That's easily to bring in solution. But we're talking veins straight through silicon oxide, meaning granite and stuff. And you see all those whitish crystal veins when you walk in the mountains, anywhere basically. You see all those white crystal veins going through it. Those are not hydrothermal veins. That's nonsense.
Right.
Well, obviously, since we talked about this before, current can make thermal because it has, material has resistance and everything. And once it starts melting a pathway, the ions are really nice and flowy. So you got a good plasma conduit. But the actual heat being hydrothermal, they see heat effects. They assume that there must be heat, but heat doesn't work that way. Heat works and transfers between, we know this using just anyone who studied heat exchangers and how to draw heat from the ground will know how heat is definitely in layers away from it. Like it transfers using the R-square law. It obviously will transfer between things right beside it before it will make a tube. Otherwise heat exchangers would be naturally occurring. These are also very interesting, these little splashes and layers and stuff.
But this is common for any type of rock, basically. Well, any kind of quartz-like rock, yeah? Silicon oxide.
We have to determine that some of them are being laid down, which is very disturbing. And then they get hit with the shock wave that seems to pull material away from it and create a layer, and which means that this thing is a very violent deposition almost. It's very scary when you think about it, because these are from mountains. To imagine mountains being formed that way is very...
When I look at this, I think of like the basin of a river, the mouth of a river, where it was an old riverbed, and possibly through sedimentary means could have transformed and metamorphosized the rock into these valleys of different. That's why we keep seeing this structure, because the structure gets fossilized, and then it gets fossilized again, and then it gets more pressure on it, and then pressure comes and keeps crunching it into itself, and that's why we get these veins, this veiny-like structure of it. Do you see what I'm saying?
Yeah, it'd be really interesting to go backwards with it. Instead of going like propose what it is. It's like how would if you looked at like I was I'm going to go after the same angle I was taking before. It's like if you see that cross section and you analyze the changes of the material as you head in towards whatever that center point is of at the radius origin, right? It would be very powerful to be able to say, okay, it was caused by this much current.
Well, that's the thing. We don't play on that level of current. Nothing plays on that level of current. This is almost a supernatural amount.
No, I know, but that's what I'm saying.
We don't. It's just been accepted that lightning bolts can make nuclear reactions. So we're at that point.
I don't think this is a normal lightning bolt.
This?
Well, this is not a normal lightning bolt.
God, no.
Because a normal lightning bolt creates a fulgurite, but it's not miles long or hundreds of meters long for starters. It's way smaller, so you need really big lightning bolts to create something like this. But I would like to point out something else from Jim Hammond, where you have a low amperage, so low current, high voltage, with the peaked up and down pulses, if you will, in a direct current situation. And it totally finds its way through a bathroom tile, for example, which is basically like rock, a hard rock. And it eats its way through. Could it not be something like that?
Well,
that it could totally be like that. That's what I was thinking, actually, because going back to fractal branding and spraying it, I am the one who's in control, and I am in control because based off the amount of water that's available. So this all comes down to water or at least some sort of material that it accretes from and creates this type of deposition or this arcing. You really got to think about what if it's an effect like you were talking about from the air. Or deep within the earth, then it might
both.
be hot. It might be hot, and it could be. I don't think detected like a bunch of thermal heat around there, but maybe we have, and that would make sense, because
we would talk high pressure here, right? This is highly pressurized, many thousands of atmosphere, whatever, deep down in the earth. And
actually, I don't know how far.
If a lightning strike-through pattern comes through, and it melts it and becomes even more conductive, so it can continue its path, that would cause even more pressure, right, with the heat there. And when something would react as in a fusion reaction, that would even make it much worse. So that might actually, be these vugs and geodes and stuff. Some material may be transported because of all that whole dynamics going on, right?
Well, I think that you're probably both. I mean, I was not being as descriptive as I could be, but both of you have made some valid points on exactly what this is probably, because usually when something comes in, it's flickering, and you're having breakdowns of its own sheath. And this thing was obviously highly charged. Imagine if we could put this in here. So you have random, not actually harmonic because it's not perfect, but you're going to have vibrations that are constantly pulling. Notice it's reaching up, like I said, to the top of the mountain. Yeah. That's a big hint. And I think that it's making the whole top of the mountain lose material. Like it's beginning to pull material off the top of the mountain, like in force. So it's like taking little pieces of rock and ripping it off. But that's because of all this current that's coming up, but it's usually coming up in pathways. So you're right. There's probably some vibration in there. It's causing this molten part. This is where it's feeding through the water, through the, probably the water table is probably where, because it has to go through this layer at the top, which is insulative and dry. Yep. And so it's ripping parts off that. So this whole mountain would look like it was on a blue fire or green fire or something, trying to reach up to whatever balloon of fire is coming across the sky. Now, it could be sustained. You're right. This whole thing could be from the whole Earth could possibly have gone through something like this. But like I said, it's hard to say exactly what came first and how. This is one of the great things about electric geology, is trying to figure this stuff out. But this type of effect, it could have been eating away at the mountain, like the mountain melting like wax, so to speak. But these are the currents reaching for that surface to provide it with the current being drawn from well within the Earth. Please go on.
Now, keep in mind that if it were to go, now this is one example I know from the top of my head, but calcium carbonate, for example, if that becomes too hot, it can decompose, especially with CO2 there, and it becomes it decomposes into calcium oxide and CO2, for example. So you get gaseous or very easily to be vaporized chemicals there that will try and find its way out, right? So that's your hydrothermal effect. Those effects are there. So the confusion is logical. So it will find its way out. And if the top layer is dry indeed, the current might more or less stop even.
Well,
right?
You see how they have to dig for them. Because they don't reach totally to the surface, because once you're going to have that spread of current once it gets closer to that thing, because it's try to find a way through this dry layer.
Yeah.
What's this occurrence of I mean, I was like 7 or 8 years old, but I went to Hawaii, went to Hilo, and then the entire Volcano National Park there. But this just immense, always there, sulfur. This was ubiquitous in the area. The smell of sulfur, which is not rotten egg sulfur. But what's like from a chemical standpoint? Is there an explanation for that? I'm sure there is, but I'm not familiar with it.
Actually, Edwin nailed it a little while ago. I think we talked about that, but
yeah,
but I think he has a better way of explaining it. There's something about sulfur shape that makes it easy to draw something into. I'm not sure if that was correct, but
what was the question about sulfur? Sorry,
sulfur's ubiquitous presence around volcanoes.
Oh, right. Well, I hypothesize that sulfur is created in situ deep down in the bowels of the earth. And one way of explaining that would be fusing two oxygens together, creating one sulfur. And a lot of heat in the process.
Would it be an electrical effect? As a
nuclear reaction. Yeah.
It would be a nuclear reaction, and the suspected way of triggering that would be electricity again.
Mm-hmm.
Which is another sort of notch in our volcano's electric thing. But interestingly,
is there a way? I'm always looking for the empirical way of doing that. Is there a way of doing that, like in the lab?
Maybe. And volcanoes are probably, they're not so much electric like, there's a little electric arc deep down underneath a volcano. Not like that.
Mm-hmm.
But if material comes too deep, it cooks, it boils, as I described. That's one way of creating a volcano. So that's what they call the depression zones, right? The ring of fire, basically, where two layers are more or less on top of each other. But also where you see a lot of deep down beneath cracks and stuff and things going on. That's more or less a volcano. So volcano can be caused that way, right? Cooking, boiling, heating, sorting. But I think in the end, most activity is caused deep down by maybe even fusion processes. There's a huge pressure there. There's a huge temperature there. And then add some electricity to the mix.
As a triggering agent anyway.
Yeah.
But interestingly, before you go, I was just remembering, it's one of those weird things that I've always remembered about strange supernatural occultism crap. Okay.
Uh-oh.
It is the connection that sulfur is involved with demons and salt is involved with ghosts, and it makes you question, because to imagine that they, just like I said before with the will-o-wisp and the idea that you killed it with cold iron, how often had that had to occur for you to come up with a plan of attack? Now, in addition to that,
look at the metaphor, then it gets into the mapping that actually maps.
Well, to go, we saw something over the hill that tried to burn us with fire, and we smelled sulfur. Like this, it's a demon, or did some, like that was a ghost that caused this. We used salt. Like, why are all this? Why this?
Why do they work so parallel and consistent?
Well, and we see we see salt domes, and we obviously, as you mentioned, the whole sulfur thing. It makes you superstitious.
Right. Well, just to get back a little bit more empirical on my side, but
of course.
But the one that Neil brings up with the capacitance, as you get this. You get this dilation of the layers where they get very close. To me, it seems like there's that pull. There's going to be that natural pulling of the material up because all of a sudden you've got this pretty dynamic change in force, right?
Yeah,
of pull because the
gravity won't matter at that point. It's going to yank things right off the ground. Yeah,
right.
And I would, the more I think about it, the more I would realize that the lightning bolt effect wouldn't be the way to create something like this is to have the atmosphere become highly ionized so that the dielectric effect is not nearly as strong. The basically air has a certain resistance per meter as you go up, and you have to overcome that with voltage to cause a thermal breakdown to get a lightning bolt. Well, the same thing would be happening here, except dirty water is fairly conductive. So these pathways would start forming, as they're reaching up through this stuff. And it's trying to get to a part where this basic silicate or calcium carbonate or whatever the hell's on top there is preventing it from going through the current. But you can see by the amount of current here going up through causing this vein, it stops so far away from the surface. So let's imagine that's where the water table was, and it can't, but it's now going to spread out along that. So the amount of current through this tube must be equal to the amount of current going through the top of this rock. But each time a current went through, it probably stole a little tiny piece of rock and went to the sky, like a sand grain, and this is why these mountains look like they were melting, for example, and stuff like that. Mm. But this is the effect.
It's just seeking equilibrium.
Seeking equilibrium, yeah. There's no mystical thing. It just would, if you were lucky enough to have survived watching something like that happen, which apparently they did, they wrote about it in books that are really, really old, then, just imagining the stuff that they went through, challenges, it boggles my mind a little bit. So
Right.
It particularly reminds me of something called geotropism and apogeotropism with the plants and how they are, because if you think about the fractal branding in 3 dimensions, like we were talking, instead of a surface thing, having it be more like a root structure or a tree structure, you do get trees, you get arborization. So in arborization, you have the pulling down to the ground, which is geotropism, and then you have apogeotropism, which is the pulling towards the clouds and towards the sun, and then you have phototropism, which is an electric effect. And I forget what phototropism affects directly, but I think that it was Bruce Laybourne that was talking about it.